Good afternoon and welcome back to DevOps Con 2021. We hope you had a very nice break. My name is Sarah Schlotthauer and I'm an editor at jackcenter.com. And up next we have Laurentiu with DevDataSecOps, How to Get There. And before I pass it over, just a quick reminder to please use Swap Card if you have any questions or comments. And at the end of the session, then all of your questions will be answered. And with that, I am pleased to pass it over.
Thank you. So hello and welcome everyone. Thank you for joining the session. My name is Laurentiu Lucaci and I'm a software engineer closing in on a decade in this career. Today, I'll be talking about extending DevOps practices and culture into data and security. This consists of my opinions, so if you'd like to question them or inquire more, I'm happy to answer towards the end in Swapcard. So in this journey, idealo has taken the first few steps, which I'm happy to share with you. Like this will be my perspective and experiences. So to best describe this journey, I think I need to give you a short recap of what DevOps meant in the past, what it is right now, and this particular version that I'm proposing for the future. And after that, I'll tackle each of these concerns individually and then leave room for questions at the end. So let's get started. Historically, most companies divided development and operations into two teams. And development would design code and test and then throw it over the wall to operations, who would then allocate some server space or deploy the code, do some maintenance. And large companies even further divided these responsibilities to a different person or role. You'd have teams working on each of these steps. So while teams of specialists got a bit more efficient at solving their piece of the puzzle, they also created silos that made the entire life cycle slightly less efficient. It would help to group the specialists together in one team to reduce some of those silos, but still, it wouldn't be the most effective feedback loop, in my opinion. So I'll be zooming into the developers here. So developers usually do the simplest thing to solve a problem, which is great, but historically this meant they were hired to write some code to solve a very specific task. And they may write some tests, but usually as a last thing. And TDD was a good improvement on that, like a fix, but still the developers didn't care enough. They would build it without fully testing the software, and that's because there were other people to take care of it. A breakthrough came when the wall between developers and operations came down. So when you stop throwing code over to operations, this extra responsibility, you get extra responsibilities, which I think creates these direct feedback loops and these aligned incentives. So basically what happened was that failing the operational pain, the dev teams were empowered to remediate it because they didn't want to be woken up in the middle of the night like the ops were. So they put a process in place to prevent breaking production systems. Things like better testing and automated testing as well, deployment pipelines, smaller and simpler components, and better monitoring. With this, dev teams became responsible for the full life cycle. It doesn't mean that developers do everything. Like there's still the notion of operations, but together, instead of assuming fixed boundaries, they collaborate and evolve those boundaries. Now, how does that look like? Well, it's a lot to do. To balance it out, you get these specialist teams building common tooling and infrastructure, which helps a lot. But you should still, so you can still specialize, but you should still understand how the system functions as a whole. So with this, you've basically optimized both the productivity of developers and the reliability of operations. And now, because of these benefits that we saw when developers became responsible for the continued operation of the product or service they built, I propose that this same should apply to security and data, and maybe even other cross-cutting concerns in the future. So why would you do that? The first reason has to do with security. As you may know, cybercrime is flourishing and it's increasing exponentially, especially during the pandemic. Hopefully you didn't get to learn that firsthand, but this does make it a necessity to pay that security debt and make systems more secure. And I think everyone is responsible for security of their products and services, especially its creators. Now, the second part has to do with what I believe is needed to succeed in this competitive digital market. Like, customers have higher expectations. That means they expect more and tolerate less. And if they can't get what they came to do, they won't come back. So I propose that a way to stay competitive is to make data-driven decisions. Okay. So in extending this shared responsibility, I like to look at it with a more scientific approach. So based on these assumptions that being responsible for security and being responsible for the product's data or service, I make the prediction, which is just like DevOps brought us better software faster, this time it will make it more secure and it will provide the insights to make data-driven decisions. So you can build the right thing even better. Now, eventually this prediction or promise will be compared to the actual results of the experiment. I'll touch upon this a bit later in the performance section. So how do you run this experiment? Well, the narrative might look familiar by now. Instead of assuming fixed responsibilities or fixed boundaries in the responsibilities, DevOps and then Dev and security, Dev and Ops, and then Dev and security, and then Dev and data, they collaborate on evolving those boundaries, all to empower them and enable to assume end-to-end responsibility, but without being overloaded by all these details. So how is this collaboration looking like more specifically? Well, similar to how it looked like for DevOps. You get the responsibility for the whole life cycle. And because this is a lot of work, it gets balanced out by training, but you also get, by the tools, sorry, but you also get the training and support you need to deal with this. So this is paired with the cultural change to support it. Now, let's take it one step at a time, beginning with data. So our goal is to build great products. We don't want to just build data sets or infrastructure for the fun of it. We want to build the right product or provide the right service. So for that, you must understand your customers and users. Like, you must really know their problems and needs. How can you learn from the user's journey and know their problems and needs? Well, you can talk to them, and we do. You can work out with some user-centric methods like design thinking or design sprints, which we also do. But you can also look at them through data. And to do that is to become data-driven. How do you become data-driven? Well, just like DevOps can't be boiled down to just a few tools, it also requires a cultural shift. And so does this data DevOps. Like, there's a lot more knowledge required. Tools and automation will avoid adding some friction into the development. So let me just start by sharing a bit about the parts of idealo's culture, which I think really helped in our case. This is not going to be a complete picture. It will take way too much time, but it is my favorite part, and I think it's relevant here. So idealo has a continuous improvement strategy. Considering how fast things are moving right now and changing, I think it's the only way to be successful. And we believe in focusing on customer value. Their expectations, needs, and desires are the starting point of all of our actions. But we also believe that data is a key asset of the company, so we must capture and analyze it. We also believe in lean agile development, like ship it fast and learn fast, but also in small cross-functional teams, which get end-to-end responsibility to make quick and local decisions. And personally, I work in such an empowered product team. And our work is guided by these principles. I put a few of them on the slide. Again, it's not a complete picture to paint, but it should get you a clue about what it's all about. So each team works as independently as possible. And as autonomous and well-trained teams, we take full responsibility for our domain. Nearly everything that happens is in this domain is going to be driven by customer needs. And to make meaningful decisions, we turned all this information we have available into actionable data. Now, each of these principles is measurable, but I'm just going to give you the example for, let's say, continuous live deployment, where we aim for an age of going live in 90% of the cases under a day, and a change size in 95% of the cases under 100 lines per code. So looking at this, you might see a resemblance to the DevOps metrics, the core ones. They basically align with the cycle time, with the deployment frequency, and so on. So that's the right culture. And in this culture, where all decisions are based on objective data insights, we need more data and data analyst knowledge and skills. Like I propose that it should be more, or not just me, but the whole company proposed that it should be more distributed across the organization. Like, why would you might wonder, like, why would product teams need to know more about data and data analytics? Well, to autonomously and independently work with data. And why? Because autonomy speeds time to market, and that in turn speeds innovation. And that's how organizations can be like data-driven at scale from a cultural perspective. But before we break the silo of centralized data knowledge or data engineering teams, we must understand how we got there in the first place. And I believe this is because of the lack of data engineering skills. To get out of this situation, you need more data engineering skills available to everyone in the organization. And for developer teams in particular, this would make them responsible not just for providing their business capabilities, but also providing the truths of their business domain and analyzing the data as collected as the software is being used. Now, B is motivated by the data-driven culture, which I've highlighted so far. And A also has many reasons, but chief of all, I would say, is that no one knows the data better than its producers. And at Idealo so far, our journey got us through A. So in 2020, we set the foundation for data and analytics. And this has been my experience so far. And hopefully in 2021, we will do a great job of focusing on getting value from data. Okay, to put these extra responsibilities that you get as a development team into perspective, I propose to look at a hierarchy of data needs. So these arrows, these red arrows, are what we did last year in providing the truths of our business domain. For consuming and getting data, getting the value from data, we haven't drawn the lines yet because we're just not there yet. It's only planned, and I'm not sure how it's going to look like. Now, as a developer, I'm comfortable with stuff like design patterns or popular libraries, profilers, and so on. But in the same way, data analysts are comfortable and fluent with things like population, types of sampling, or p-values, decision trees, and so on. So I think it will take some time to learn all of these before we are ready to consume and get insights from this data as developers, as the developers as well. So for now, it's just providing the data sets, which is a challenge enough on its own. And notice that the transfer knowledge dotted connection here on the right, because I'm going to focus on that next. So with the help of our data experts, we gain this knowledge. And our current solution is to embed data engineers in each team, kind of like a resident, like for a limited amount of time. And because of this decentralized structure, as I mentioned, each team needs to gain a lot of knowledge. And there were challenges with that. And I would say even limited success in this knowledge exchange, knowledge transfer, or cross collaboration. And this was sadly due to some lack of communication but also because we're missing community, or we were. Even, I think last week or 2 weeks ago, we started as a company to address this. So to provide the truths of your business domain, the kind of responsibilities that you get and you need to look at when you build it. So you, as I've mentioned, you really know what's in the data. So you have to be the one that's also describing what's in it, because you're the only one who can guarantee that what got delivered is correct. In our case, we needed to build a technical infrastructure with some tools and templates from the core engineering team, like data engineering team. We needed to ingest a bunch of files, and because big data can be slow if it's not prepared for consumption, we also needed to learn about optimizing for data analytics or machine learning use cases. So this meant we had to think about partitioning the data or using columnar data stores, compressing it, the trade-offs between the number of files and the size. And this can mean quite a lot of work and lots of things to do and learn. So for me, it felt like I was taking away from the main value-producing activities that I do in my day-to-day job, even with this all this tools and automation. However, I got a new perspective when I started to look at data as a product and the rest of the organization as its customers. So I became more eager to give the best user experience for consumers. I cared more about things like making data discoverable or trustworthy and truthful and all that. So owning the data and data pipeline adds a lot to what we're expected to do. And as I've mentioned, to balance it out, we need the right tool chains to simplify and automate things. So the centralized data engineering teams came to the rescue here. Like, they really turned their specialized knowledge into a reusable data infrastructure platform. And this was kind of like self-service tooling, which helped us really ingest, transform, process, and serve data. It helps us with, so basically through them, we set our own infrastructure and pipeline and storage and so on. And we're also guided by this principle of paved roads, where you don't have to use it, like they provide it, they know best, but you can also make your own in case you have you are more opinionated about the tool. However, you are responsible for all the costs of maintaining your own alternative tooling, of course. So how do we know if it was all worth it, if the predictions were right? I would say by measuring it, as I mentioned, the scientific approach in the beginning. So in the current phase of sharing our data, users need to get value. So I would say that the one metric that matters is the time to reliable insight. Now, this is basically the lead time for consumers of our data product. How long does it take them to get the data successfully? And it can be broken down in a lot of ways. I'm only going to highlight a couple, and even within our my team, at least, we don't measure everything, but at least a couple of things we know. So we know the time lag to analyze, which I think is somewhere less than 30 minutes, and aiming to be even more near real time. And this time lag to analyze, it just means how quickly is the data source available, the data available from the source to its use case of analytics or machine learning. And of course, the objective would be to have it as real time as possible. And this does come with some trade-offs that you need to be aware of. For example, in our case, with some cloud infrastructure where you pay per request or per event, it helps to buffer it a bit. So actually, this buffer is that max time. So in terms of success, I would say I'm going to share with you my opinions and experience from all of this. In terms of what I see being successful, I'd say the biggest one is that we have the cultural foundation to become data-driven as a company. And the next one would be that as a product team, we've managed somehow to share our data and assume this new knowledge and learn about these tools and do a decent job of collaborating with the data science team. And now we can basically work independently with data. Now, speaking of challenges, it took some time, at least I'm speaking again from personal experience, to get familiar with the data platform concepts. And first, we had this, let's call it the current generation of data platform, which everyone knows as the data lake. For it, the stages like ingest, process, and publish, to me, it made sense. But now we're also in the process of moving to the next generation of data platform or data mesh. And this is another challenge. And for me, it's a lot of ways in which you change your thinking or perspective on this. And what else? I'd say another challenge would be that you basically have to have data at the back of your mind all the time. Like when you serve it, when you change something, you also have to remember to provide the metadata. And yeah, this has been my perspectives on data. And now I'm going to move on to the second half, which focuses on security. So security was not often able to keep up with the speed at which code is released right now. And DevSecOps, as you may have heard it in the industry, is the attempt to correct that. And it extends the culture of shared responsibility, just like data did. But this time, it includes the security practices and not just development and operations. And what we hope to achieve is to deal with the security risks before new components go live. But how do you do that? How do you address the security risks before they go live? Well, I'd say first you have to integrate the security testing into your CI and CD pipelines. Then you have to build the knowledge and skills for it so that the results of testing and fixing, like those findings or risks, can be done internally. Now, security integration also needs the right culture, just like data integration did. Now, ideally, you identify, as I mentioned, you identify and solve the security issues early in the life cycle of development, rather than after the release. And there's a good reason for that, because this technical debt that gets accumulated, that's the reason why most software products are hacked. And it's embarrassing to know that most of them, at least from my perspective, exploited hacks that have exploited vulnerabilities that have been known for more than a year. So in my opinion, a real DevOps environment needs a few things. It needs the security testing to be done by the development team. And the same development team needs to be able to manage those issues that you find and then also fix them. But fixing them can be particularly challenging because it's difficult to do all of this autonomously. Like you need to prevent, discover, and remediate all these security issues. So developers sadly must build a skill set to do it, to fix those security related bugs, and to do it without guidance, it takes time. Now, our first attempt at this, at getting devs to learn a bit more about this, has been met with resistance and failure, I would say. And it was the Hacker Guild. It was basically meant to teach devs how to hack systems by themselves. But there's a gotcha here. Like as a developer, you work in a constructive way. Like your mind tries to come up with new ideas and features, but when you hack it, you think in a destructive way. And there is a kind of conflict in thinking that I would say is not for everyone. Most devs just want to have the knowledge of how to build it right without having any vulnerabilities in it. And they don't want to jump in and try to find some sophisticated attacks, like do some null byte creation or whatever preconditions are needed to change some vulnerabilities. And because of that, we've concluded that it doesn't make sense to have many devs in the team capable of doing these sophisticated attacks on the system. Now, our current approach relies on embedding a so-called security champion within development teams. This is someone who has expertise and more advanced training than the team. And training includes stuff like application security and information security, meaning risk management procedures, security and data protection audits, threat modeling, ethical hacking, and so on. Now, this is how we're currently trying to scale this knowledge into the teams across all areas. And I took this role within my team. So what am I up to as a security champion? I do some security audits. I'm active in the technical risk management, and I constantly learn about security and share what I've learned with others. And there's a lot of low-hanging fruits in security, and that's why, in terms of tooling, we want to have a full stack basic security audit for every system. And that means that multiple scanners are in place and doing all those different scans. And as a security champion, I also help create this pipeline, which runs that audit automatically. And to tell you a bit more about the pipeline, well, throughout the lifecycle of a component, as you get more information, or more information becomes available to be audited, you can do more sophisticated audits. So you do some dynamic application testing with burp, or I don't know, if we need to introduce a software as a service, we need to know how they handle security or data privacy. And then there's pen testing with some manual payloads. And anyways, enough about security champions. Let's look at what developers do. So in an ideal world, as a developer, you would run this pipeline I just described yourself. And then you get some findings. Then you must really think about it, evaluate the issue, do some risk management, and finally address the risk. But all these findings, they need a different type of knowledge to use them. You have to know at least what it's for and what attack it does. And right now we don't have a plan to train for every single scanner, but we're getting there. But we do have a system to ensure continuous education, a build system. Anyone can basically apply for it. And we've only defined the first two steps. And no further, we say what are the preconditions to get it, what you're supposed to do. And we consider that eventually reaching a black belt, you just hope other people get there. So it's not enough to just have super high proficiency. And as with data, you got to know if all this complexity was worth it, if it was successful, if that security debt got cut. And now that's something we measure, but also we look if all the components run those audits, like if that pipeline is used on all the components. And soon we're going to do it even more frequently because we don't want any low-hanging fruits for any script kiddie to just exploit. And obviously we also measure the exploits and attacks on the system to determine how secure it is over time, although this is not necessarily correlated directly with practice, but there should be a positive impact in that direction. So we're also thinking of the DevSecOps maturity model. This looks promising, but maybe a bit also over-engineered. So this measures some static, how deep is your static code analysis or your dynamic scans, or how intense, like the majority of your tasks are. And we've talked to people in the practical DevSecOps, and some of them even tried for the third time to implement the security champions program successfully. Now, they tried to build their own version, and we might just do the same, because perhaps it's not necessary to go into all activities in parallel, and maybe you can just select the most valuable one and then bring it to the highest maturity level and then iterate. Okay, so again, I'm going to give a few thoughts from my experience on this in terms of what was successful. And I would say that we're seeing knowledge being distributed pretty well, and people already acknowledge that it's important they take ownership and even become proactive. I'd say another success is that we've built a pipeline. This has been finalized in this last year, but also there were challenges. Like it was, I think it was hard to find time to maintain the program, at least for me. You don't want to lose out too much on the impact you're making with delivering value, and that's where one of the challenges comes from. And another one is maybe not so actionable, but the idea is that the less data you have to keep secure, the safer your company will be. But this goes a bit against a data-driven approach where you want as much as possible. So that's kind of a side note. So another challenge is that not enough people are getting into the topic, so it's hard to develop it. So this was it. I'd like to thank you for your attention, and I hope you did get some insight from it. And if you did, I'd love to learn what. Please write some notes, drop some lines on the live discussion box. And also, if you have any questions, feel free to add them. And for the remaining of the time, I'll do my best to address them.
Okay, thank you so much for a great session, and thank you everyone for attending. We do have a question in the chat. I'm going to read it out to you. How are you applying the security scans? As part of the CD pipe, interfering with time to deploy, or as an aside process?
For now, as an aside process, but ideally, at least within my team, this would be part of the pipeline. I mean, that's the ideal situation. And I think some other teams have managed to do that, if I'm not mistaken.
Okay, I hope that answered your question. I'm going to give the chat just a few seconds to catch up in case someone is typing out their question. But in the meantime, perhaps we can get some applause emoji in the chat. That would be great. Just going to give it a few seconds to catch up. There's a little bit of a delay between our video and when it's streamed out, so you never know who's typing until about 30 seconds later. Okay, we have our next question came in. Don't you think that instead of adding more middle words to, sorry, a bunch of questions came up and my chat flew up the screen. Okay, first, do you think that instead of adding more middle words to DevOps, such as sec and data, do you think it's time to accept that ops also involves sec and data?
Yeah, why not? I mean, first off, this new term, I don't care if it sticks. I actually don't want it to. It's just a convenient label I apply to distribute these principles, and I've shared it from the perspective of developers because I'm a developer, but I don't see why not. Hope this answers your question.
Okay, our next question. How long is your onboarding of new folks in teams since they potentially have to learn such a broad knowledge base?
So when I joined, it was quick and easy. Right now, I actually don't know, since this is pretty new. In the last year, we've adopted these changes, and I haven't seen any new people joining in my product area. But I'll try to get back to you on that and answer in the live discussion box when I get that info. Presumably, it would go higher, but it doesn't necessarily need to be a big bang, like everyone is equally knowledgeable at the same time. Like this distribution can probably also happen over time. That's how I see it.
Okay, moving on to the next question. How are you fostering a culture that understands and really pursues security as being something valuable? And what do you do if devs just aren't that interested in it?
Okay. That's a tough question, but also a good one. You can't, I don't know what you can do if devs aren't that interested. Personally, I am interested, but I also know in various teams, those which are not interested. So probably in those teams where fewer people are interested, more load would come on security champions to deal with it. And then I don't know by which way this knowledge would then become equalized. I just don't know the answer. And for the first part of the question, could you please repeat it again? Because I don't have the screen in front of me actually with the chat.
Of course. How are you fostering a culture that understands and really pursues security as being valuable?
Well, beyond some sessions, so we have some regular knowledge sharing sessions within departments and PAs, and beyond raising awareness there and sending emails and having like the community for it, whether in chat with the resources, I don't know what much more you can do to have this. Probably some evangelists are helping with that as well.
Okay, we have two more questions. The first being, if you use third-party libraries, how do you make sure that all security aspects are fine?
The specifics of this, I don't actually know because I haven't had to evaluate this. I think I've seen conceptually the kind of boxes you have to tick at the end, like you have to say, yes, it's compliant with data and privacy stuff, but I haven't actually had to do it. So also I'll follow up with this on the chat. I think you can access it even after the session ends. So that's my answer for this question.
Okay, and one last question. As a security champion, do you still do non-security related development? And if so, how much time remains for that?
Well, I would say most of my development is non-security related. I do about 4 hours a week for security champion stuff. And then the rest is just my responsibilities within the team.
All right, thank you so much for answering all those questions. And thank you so much, everyone, for asking all the questions. I love just seeing the chat bump up with all the questions. It's great. All right, that's a wrap. Thank you so much for a great session.
Thank you, and thank you for your attention and for this conversation as well, because you've interacted and put questions, so much appreciated.
Thank you. All right, have a great rest of the day.
You too. Thanks, everyone.